Hi Calc students and Happy New Year. This is video 5-1 for Tuesday, January 3rd. Oh no, January 3rd, 2017. I'm making this very late at night, so I'll try to do my best. The homework is to finish example number 2 below. And what we're doing today is we are estimating the area under a curve. A curve is just a graph. So we're estimating the area between a graph and the x-axis. And the way that you estimate the area is you use a bunch of little rectangles. You could use other shapes like trapezoids or other things also. We'll use trapezoids tomorrow, but today we're just using rectangles. And so here we're using a bunch of rectangles to estimate the area under this curve. Here we have a bunch of rectangles estimating the area under the same curve, and this is the better approximation because we're using more rectangles. So the more rectangles you use, the better approximation you'll have. Now this example number 2, I will start with you. Here it is. I will start this with you later, and then you'll have to finish it for homework, but we're going to flip to the other side. Okay? And there are Riemann sums. Okay, so estimating area under a curve using rectangles. What you do is you add up all the areas of the rectangles, and adding up all the areas of those rectangles is called a Riemann sum. Okay, so approximate the area under the curve on the given interval using the given number of rectangles. This is called what LRAM stands for. What does it stand for? It's the left Riemann sum approximation. RRAM is the right Riemann sum approximation, and MRAM is the midpoint Riemann sum approximation. So I'll show you how to do this. This is kind of a long process, so just bear with me. The first thing that you want to do is so in each case we have the graph of the same function. The interval that we're estimating the area under the curve on is from 1 to 3, and we want to use 4 rectangles. So the first thing you've got to do is figure out what the delta x is going to be, and the way you do that is going to be 3 minus 1, so that's the length of the whole segment, but we want 4 rectangles, so we divide it by 4, so that'll be 2/4, so 1/2. All right, so we're going to use 4 rectangles in each case, each having a length of 1/2. Okay, so and I already did like the arithmetic in my calculator, so yeah, I'm gonna kind of save time by just looking at the paper that I've already done this on. So LRAM, the first thing we're gonna do is divide this into the 4. So we're gonna take this interval and divide it into 4 sub-intervals. So the most accurate way for me to do this is first I divide it in half, and then I divide the halves in half. Okay. Now, to get from 1 to this end point of the first subinterval, you have to add a half. So 1 plus a half is 3/2. Okay, and I'm going to do this fast. I've already done it. 3 plus a half, because that's how long this is 2. 2 plus a half, because that's how long that is 5/2. And then you add another half, and you'll get to the very end point. Okay, now what it means to use a left Riemann sum approximation is that, so we have to determine this is going to be, so this is going to be the base of my first rectangle, okay? And the height of the rectangle is going to hit the graph somewhere, between here. So the x values somewhere between here are going to determine, the output, which would be the height of the first rectangle. But since this is a left Riemann sum approximation, or you look at the base of the first rectangle, go to its left end point. I'm going to put a dot there. So this left end point is what's going to determine the height. So you go to the left end point, then you go up to the graph. Once you hit the graph, that's the height of the first rectangle. So now you just have to complete your rectangle. I usually go over, horizontal, and then down like that. So that's the first rectangle that we're using. So the second rectangle, so I recommend that you do exactly what I'm doing. So outline the base, go to the left and put a dot. Okay, so the output, the function value at this input, so that output will be the height of the second rectangle. So now I go up to the graph, that'll be the height. over, down. Okay, so that's the second rectangle. Third rectangle, here's its base. Go to the left. That's going to give us the height. All right, and finally our fourth endpoint, or our fourth interval, go to the left all the way up to the graph. All right, so notice I don't have a dot on 3 because I didn't use that. I did not use this endpoint for anything. I'm always using the left endpoint of each subinterval for the height. Okay, so now the left-hand Riemann sum. We're going to take the areas of all 4 rectangles and add them up. So I'm just going to go like this. I'm going to go rectangle 1, rectangle 2, rectangle 3, rectangle 4. And you probably remember that the area of a rectangle is base times height. So I'm doing a little chart like that. So the base, guys, each base is the same length. Each of the bases are delta x. All right, and that's always going to be true. So the bases are all a half. But then the heights of the rectangle, you have to plug in, like, how do you know what this height is? How do you, like, the height is this y value. Well, how do you get that y value? You plug it in to the original function, which is right here. Okay, so they're all the graphs of that function. So for the first height, I plug 1 into the original function. For the second height, I plug 3/2 in. So I keep plugging the left endpoint of each subinterval into the original function, and that will give me the function height there. And I've already done it in my calculator. So I got 14, I got 12.75, I got 11, I got 8.75. Okay, so then here the area sum is going to be equal. I'm going to show you a shortcut. You could like do base times height, base times height, base times height, base times height, and like add them all together. Or since you're multiplying each height by a half, you could just use the distributive property, factor out the 1/2, and then inside you will just have the sum of all the heights. And if that doesn't make sense to you, just go a little slower. You know, like try to get this a little bit longer way. So it's going to be 1/2 times 46.5. Okay. Now down here we're going to state the approximate area, which is just 1/2 times 46.5, which I've already done, is 23.25. And then, this is an important question. This is an estimate. This is not the exact area under the curve. So this is an estimate, clearly. But is it an overestimate, an underestimate, or can we not tell? This is an overestimate. And if it's not clear to you why, you need to think about it. Okay, 2 more, guys. I'm like out of practice with these videos. Okay, right-hand Riemann sum. We're going to start it off exactly the same. All right, we've got all the same numbers here. But instead of using, so when you look at the base of the rectangles, instead of going to the left and up to the graph, you go to the right endpoint and up to the graph. Okay, so there's our first rectangle. So same thing as before, but when you look at the base, you think about the base and then you go to the right endpoint of it. So there's the base, go to the right, up to the graph. Okay, there's the third base, go to the right, up to the graph. Here is the fourth base, go to the right, up to the graph. Okay, so there's the 4 rectangles. So same thing as we did before. And speed the video up, guys, if you'd like. We're going to have the first rectangle, second, third, fourth. Okay, the base is always going to be delta x. All right, that's what we found at the very beginning. So again, they're all a half. And then for the heights, the heights are going to shift a little bit. They're not going to be exactly the same down here, because for the first rectangle, instead of using the left end point to get the function value, which would give me the height, I'm using the right end point. So 3/2 has to get plugged in, then 2 has to get plugged in, then 5/2 has to get plugged in. So like you're going to see some of the same values that we used before, but for different rectangles. 8.75. And then I didn't use, remember for the left one, we didn't use the rightmost endpoint. But, you know, here we did use the rightmost endpoint. It was the leftmost endpoint that we didn't use. Because on that first subinterval, you go to the, you know, the right endpoint. Okay, so the area sum is a half. And then when I added up all of these heights, I got 38.5. And then I got 19.25. And this is clearly an underestimate. Okay, so there's that. And if that is not clear why, that's something we should discuss in class. Okay, but that should be clear to you guys. Even though I'm not articulating it myself, it should be clear to you that this is an overestimate, this is an underestimate. Okay, now finally, the midpoint one. This one's going to be a little bit different. Okay, so I still do the 4 subintervals, but it's their midpoints that I'm going to be using to get the height of the rectangles. All right, so I've got to use all of these midpoints. All right, I already took the liberty of figuring out what they were. So all that I did, guys, I knew that this was 1, and I knew that, so to get the midpoint between 1 and 3/2, there's a lot of ways you could do it. I just added them and divided by 2. I just averaged them. So I averaged those, and then I got the first midpoint. And then I knew to get from the first midpoint to the second midpoint, I just would have to add a half, so I kept doing that. But you could figure it out other ways too. But I got 5/4, and please let me know if I made a mistake. 7/4, 9/4. I hope I didn't make a mistake. Right? Yeah. Okay, 9/4 and 11/4. Okay, so this time, this is going to look a little bit messy. I'll use colors at the end to highlight it better. But this time, we're going to look at, okay, so here's the base of the first rectangle. It's still the same length, like the same subinterval. But within this first subinterval, instead of using one of the endpoints to go up to the graph, you use the midpoint to go all the way up to the graph. And then that's the height of the rectangle. And then you've got to complete the rectangle by like going off to either side. Like that. Okay, and I'll color code this at the end so you can see it more clearly. So second rectangle, there's its base. It's that whole second subinterval. Go to the middle up to the graph. Okay. Third rectangle, go to the middle up to the graph. Oops, sorry, I'm shaking the camera. Fourth one, go to the middle, up to the graph. Okay, and just so you can see this clearly, just let me show you, like there's the first rectangle, there's the second rectangle, third rectangle, fourth rectangle. Okay, we just use the midpoint to get the height. Alrighty, so again, rectangle 1, rectangle 2, rectangle 3, rectangle 4. So the name of the Riemann sum, guys, a Riemann sum, let me just summarize, is to use rectangles to estimate the area under a curve. And the name of the type of Riemann sum, whether it's left hand, right hand, or midpoint, just depends on where within each subinterval you're going up to the graph from. Okay, so again, these are all 1/2 for delta x. And then the heights, I had to plug 5/4 in for the first rectangle, 7/4 in for the second rectangle. So I plugged all those midpoint values into the original function to get 13.438, 11.938, 9.938, 14.75. So then the area sum is 1/2 times all the heights added, 50.064, 25.032. Okay, well, the first one clearly an overestimate. The second one, clearly an underestimate. This one, this is actually can't tell because some of each rectangle is under the graph, but then some of each rectangle is over the graph. So this is a can't tell situation. Okay, guys. Now, this is your, I'm going to get you started on your homework. All right, so this is example number 2. So approximate the area under the curve on the given interval using n rectangles in the indicated evaluation rule. So we're going to, and then we will state whether the Riemann sum that you computed is an overestimate, underestimate, or can't tell. Okay, so y equals x squared. Off to the side, guys. Oh, and it's on this interval from 0 to 1. Okay, so I don't need to see the whole thing. Leave yourself plenty of room. I'm really going to stretch this out. So like a really kind of flat looking parabola. So this will be 0. There will be 1. And we are using 8 sub-intervals this time. Okay? And as soon as you feel like you've got this, just stop and go ahead of me. All right? So I got to cut this into 8 pieces. So I'll cut it in half, and then I'll cut the halves in half, and then I'll cut the quarters in half. Okay? And then I've got to figure out, so I know this is 0, but I've got to figure out like what that is, and what that is, what that is. So I have to figure out delta x. To figure out delta x, you always find the length of the interval you're on. It's always the right endpoint minus the left endpoint, so b minus a. So 1 minus 0 over how many rectangles? So 1/8. All right, and I already did this earlier. Okay, so to get from, so the length of this segment is 1/8. So from z, if I want this length to be 1/8, that's got to be 1/8 right there. Okay, and I just keep adding on another 1/8. So that becomes a 1/4. This is 3/8. 4/8 is a half. 5/8 won't reduce. 6/8 is 3/4. 7/8. Okay, we are using the right endpoint evaluation. And again, you could stop the video at any time if you've got this, okay? So I'll just draw my little rectangles first, and then I'll do, so we're going to have rectangle 1, rectangle 2, rectangle 3, rectangle 4, rectangle 5, rectangle 6, rectangle 7, rectangle 8. Okay, so just like that. Okay, so the base, whoopsie, if you can't see, equals delta x. So it's going to be 1/8 all the way down. But then for the height, we've got to get the function value. So this is the part where the visualization really helps. And also when you're thinking of an over or underestimate. So right endpoint. So I'm going to outline the first base, go to the right endpoint up to the graph. Okay, so there's the first little rectangle. And again, stop this and go ahead of me if you'd like. Second interval, right endpoint up to the graph. I'll do one more. Third interval, right endpoint up to the graph. So guys, of all these little endpoints for the subintervals, there's only one that is not going to have a dot on it. That's the 0, because that we didn't use. Just like on the back, how like sometimes you leave off an end point, you know, depending on which estimate you're using. Okay, guys, it is your homework to finish the rest of this. Okay, so fill in the heights, get the area sum, say whether it is an over or an under estimate. Alrighty, guys, Happy New Year. I will see you tomorrow.